So how do you find the differential of a bracket raised to a power with a function inside? So the rule is that in such a case, dy by dx is gonna be, start by writing the function, then bring the power down, reduce the power by 1 as you always do. Finally, the differential of the bracket is multiplied. In this case, it's a. So this is going to be the general form of dy by dx, or you can also write it as an. So, or for now, I'll just leave it like this. We'll take a few examples, starting off with this. So in this case, dy by dx is 2x plus 3. Bring the power down, so it's going to be 7 here. 7 minus 1 is 6, and multiplied by differential of the bracket, which is 2. Thus, our final answer is 14, 2x plus 3 to the whole power 6. Moving on, 5x minus 2 raised to the power 10 dy by dx in this case is, bring the power down, 5x minus 2, 10 minus 1 is 9, multiplied by differential of the bracket, which is 5. And our final answer turns out to be 50. 5x minus 2 raised to the power 9 is our final answer. Then example 3. First of all, we'll rewrite this as 4x plus 1 raised to the power half. So this is our equation of y. Then we'll find dy by dx. This just makes it easier to solve. Half, after we bring the power down, and 4x plus 1, subtract the power by 1, and differential of the bracket. So it's 4. 4 into half is, turns out to be 2 after we simplify this. And finally, we have 2 above. The power is negative, so to make the power positive, it goes to the denominator. And since the question was framed in a square root form, we leave the answer as a square root 2. Remember, the distinguishing qualities of a distinction holder are they leave the answer in the form of the question. Then we have our last and final example for this model. We'll start by rewriting this again, and then we'll simply find dy by dx. The first step is bringing the power down, reducing the power of the bracket by 1, and multiplying with the differential of the bracket. Half into 2 is 1, and our dy by dx turns out to be 1 over root 2x plus 7. And this is going to be our answer. Then we have model 6, or an extension of model 6, of model 5. I correct myself. That is, what if we don't have a linear function inside the bracket, but instead we have any other function? It can be a quadratic or a function with a maximum power of 3. In such a case, where fx can be any function, then dy by dx is going to follow the same rules. That is, we'll bring the power down, fx remains inside the bracket as it is, and the power is reduced by 1, and we multiply this by the differential of whatever is inside the brackets. Alright, f dash x. This is the notation for differential of f of x. So let's say in this case we have dy by dx, bring the power down, and then whatever is inside the bracket remains as it is for this case, and reduce the power by 1, then multiply this by differential of the bracket, that is 6x, and minus 5x as the differential of minus 5. Thus, final differential, let's simplify this by multiplying 7 to this. So we have 7 into 6x is 42x, and 7 into 5 is minus 35. And this part remains as it is. Then our last and final example, start by rewriting this again. So it's 4x square minus 6x plus 5 to the power half. Then finding dy by dx. First of all, bring the power down. Whatever is inside the bracket remains as it is for now. Reduce the power by 1 to become minus half, and multiply, or rather first of all find the differential of the bracket. That is, in this case 4x square has the differential of 8x, and minus 6x has the differential of 6. And multiplying half with this bracket to simplify this, we have 4x minus 3 and 4. Let's remove the brackets since we don't need them anymore. Over 4x square minus 6x plus 5. And this is our final answer.